All right, so in this video, I am going over multiplying and dividing rational expressions. So if you remember when you were multiplying fractions, when you first learned how to multiply fractions in grade school, um, if you were given a fraction, say 2/3 times 3/4, you did not have to have a common denominator. You just simply multiplied across. So the 2 times 3 would be 6, and the 3 times 4 would be 12. And then if you can reduce it, which you can, they both have a common factor of 6. So the 6 is basically 6 times 1, the 12 is 6 times 2, so we can reduce by a factor of 6, which then gives you a simplified fraction of 1/2. So that was a basic example of simplifying or multiplying a couple of fractions. Well, we're going to be doing the same thing here with rational expressions. The only difference is now we have variables, and when you have variables, you have to be careful not to get any undefined values. So anytime you're going to have things that make the denominator 0, you have to make a statement stating that cannot equal, or x cannot equal 0, or y cannot equal 0 based on this. But the property of multiplying is basically the same as what we did over here. You're basically multiplying straight across, and you're simplifying AC over BD. But notice it does say B and D cannot equal 0 because they are in the denominator. So like in this first example, if we multiplied straight across, 5 times 6 is 30, x squared times x is x to the third, and then you've got your y to the third here. If you multiply the 2xy squared times the 10y, you get 20xy to the third. So if we look at for common factors, the 30 and the 20 can be factored into 10 and 3 and 10 and 2. So they have a common factor of 10. Your x to the third is can be factored into x times x squared to reduce with the x that we have in the denominator. And then the y's, you have a y to the third in the numerator and a y to the third in the denominator. So those can be reduced, and you're left with 3x squared over 2 as your simplified fraction. But then you also have to state that x cannot equal 0 and y cannot equal 0 so that you won't have any undefined values, and so that it will be equivalent to the original statement. So here's an example, example 2a here. If I, like I said, if I multiply straight across, I would take my 6 times 5 and get 30. The x to the 6th doesn't have any other x's to multiply with. The y to the third times y would be y to the fourth. If I multiply my 15 times my 9, I get 135. And then the x squared times the x would be x to the third. The y times y to the 7th would be y to the 8th. Then we need to find common factors here. Well, before I multiplied the 15 and the 9 together, I had a factor of 15. Well, 30 also has a factor of 15. So I probably shouldn't have even multiplied the 15 and the 9 together. I probably should have just left it as 15 times 9 and left it in factored form. So then my numerator now can be factored. So the 30 is going to be factored into 15 times 2. My x to the 6th, so that I can reduce with the x to the third in the bottom, I can factor that into x to the third and x to the third. Y to the fourth, I'll leave alone because that's the smaller amount. The denominator now, I've got my 15 times 9, x to the third, but then my y to the 8th, so that I can reduce with the y to the fourth at the top. The y to the 8th, I'm going to factor into y to the fourth times y to the fourth. So now, before I start crossing anything out, I do want to state my undefined values. So I have both an x and a y in the denominator, but nothing is being added or subtracted. So when all you have are monomials and there's no plus or minuses in between, then your undefined value x and y can just the only conditions that you have to state are that neither x or y can equal 0. All right, so now I'm going to go back and start reducing. 15, x to the third, y to the fourth. So my simplified rational expression would be 2x to the third over 9y to the fourth, with the condition that x cannot equal 0 and y cannot equal 0. All right, so that one was one with monomial examples. This next one here is one that I have binomials. Again, I'm multiplying, but I've got to factor the numerator and denominators in some of these before. I don't want to just multiply straight across because we want to factor these things and see if they reduce with some things on the bottom. So if I start with the first numerator on the left, out of those two terms, I can factor out an x. And then after I factor out an x, I'll have x minus 2 in parentheses. Now I can write this all in one fraction. The x to the third plus 8, that is a difference of cubes. So let me use a different color here. So this here is a difference of cubes. So it factors into a binomial and a trinomial. When you take the cubed root of x to the third, you get x. The cubed root of 8 is 2. Then take your x and square it, you get x squared. Then 2 times x gives us 2x in the middle, and then 2 squared is 4. As far as the signs go, since we have a plus here, the first sign is the same, the second one is opposite, and the third one is always positive. So I can put all of this in the numerator together, but I do, because it's multiplication, but I do want to factor these things out. All right, now going back to the denominator, I have an x plus 7. That cannot be factored. So that's just going to stay the same, keep it in parentheses. But I can factor out an x from the x to the third minus 4x. So I'm just going to put that in parentheses, even though technically I probably should put it out front, but it's going to go away in a minute. And then I would be left with, actually, I'm going to go back over here. I want to go back over here to save some room. So if I look at this denominator over here, I can factor out an x from the denominator, which then will leave me with x squared minus 4. Well, that x squared minus 4 is a difference of squares, so that factors into x plus 2 and x minus 2, but I still have that x out front. So this denominator factors into x, x plus 2 and x minus 2. So now that everything is factored, before you start crossing anything out, you do want to make sure you look at what your undefined values are. So, and again, they only come from the denominator. So if I look at my x plus 7, well, what value of x will make x plus, or what number would you add 7 with to get 0? Well, negative 7. So I do want to state the condition that x cannot equal negative 7. That would be an undefined value because that would make the denominator 0. The x here, that's all by itself, so it's not being added or subtracted anything. So that one is just 0. So x cannot equal 0. And then for these two, you have negative 2 and positive 2. So we could just make that one statement, x cannot equal positive or negative 2. All right, so these undefined values are very important when it comes to graphing and solving, which we're not quite doing the solving yet, but we're going to get there. All right, so now that I've stated my undefined values, now I can go through and reduce. So I have this x out front and this x here that I can reduce. So those go away. The x plus 2 I can reduce. I have a factor of x minus 2 at the top and the bottom. That gets reduced. So really the only thing that I have left is this trinomial here and that binomial there. So my simplified rational expression would be x squared minus 2x plus 4 over x plus 7. So that's simplified, and these are my undefined values. All right, moving on then. The next couple examples are dividing. Now, when you're dividing the Undefined values are just a little bit more complicated. So here's just a quick example of dividing. You've got a fraction divided by another fraction. So the first fraction, a over b, stays the same, but then we're going to change this division to multiplication, and you want to take the reciprocal of the second fraction and rewrite it as d over c. So dividing is the same as multiplying is equal to multiplying by the reciprocal. And then when you multiply across, you get AB and BC on the bottom. So now, if you look at the undefined values, you've got three places to look. You've got the denominator here, which is B, the denominator here, which is D. So in the original expression, B and D were in the denominator. But in your new expression, C now is in the denominator. So the only thing that could equal 0 would be A. But all denominators, B, D, and C, none of that can equal 0. So in this example here that I have, I've got 7 over x plus 1 divided by x plus 2 over 2x minus 3. There's no factoring that we can do, so I just rewrote it as 7 over x plus 1, change your division to multiplication, take the reciprocal of the second fraction, 3x minus 3, or 2x minus 3 over x plus 2. And then I just kind of multiplied straight across. But here's where your undefined values get a little tricky. So x cannot equal, if you look at the original expression, -1 would make this fraction undefined. So -1 is not, x cannot equal -1, or -1 is not in the domain of x. The 2x minus 3, if I set that equal to 0 and solve, I would get positive 3 over 2. So x cannot equal 3/2 either. And then if you move it to the new expression, we now have an x plus 2 in the denominator also. So that gives us a third undefined value of -2. So all of those numbers would make the function or the expression undefined. All right, so now we're going to do a couple of division problems and assume that all the variables are, it says assume all variables are defined. Actually, I'm not going to do that because you have to state undefined values in the assignments that you are doing. Okay, so let's factor the numerator. So if I look at my numerator, the 6x squared minus 11x minus 10, there's nothing I can factor out of all three terms, but I can factor this with AC method, because if I multiply the 6, which is my A, times the -10, which is my C, I would get -60. So that's my AC. And there are two numbers that multiply together to equal 60 that subtract or have a difference of 11. That would be 15 and 4. So I'm just going to take a minute and I'm going to factor this right here. So the 6x squared would stay the same. I would have a -15x plus 4x in the middle to give me that -11x. But then the -10, don't forget, that does not change. Then I would factor by grouping. So I'd factor out a 3x, and I'd have 2x minus 5 left over. Then I would factor out a +2, which would also give me 2x minus 5 left over. So when I factor out the 2x minus 5, I then would have 3x plus 2 in my other parentheses. So these two factors of 2x minus 5 and 3x plus 2 come from factoring just that numerator. So now if I take my denominator and put it on the bottom, then I'm going to move over to my second fraction. So if you're dividing, you want to change your division to multiplication, but then we have to take the reciprocal of this fraction. So one of the things that students forget is that if you have something that is not a fraction, you can always make it a fraction by putting it over 1. So if I take the reciprocal of this, the 1 then ends up in the numerator, and the 2x squared minus 5x would go in the denominator. Now, before I bring that down, I probably would suggest that you factor out an x from both of those terms. and then you would have 2x minus 5 in parentheses. All right, so now we are here. So really we have all of this in the numerator, all of this in the denominator. We could make this one nice big fraction if we wanted to. So looking at the numerator and denominator, what do we have in common that we can reduce? Well, we've got a 2x minus 5 here. Oops, wait, before we start crossing things out though, we should probably state our undefined values. So in the original equation, we just had a 5x squared. So you cannot have a denominator of 0, or you cannot have an x value of 0, since that would make that fraction 0, denominator 0, making it undefined. And then after I take the reciprocal of my second fraction, I now have this 2x minus 5 in the denominator. So x cannot equal positive 5 halves either. So those are your undefined values. We have to state those to make this equivalent to the starting expression. All right, so now the 2x minus 5 in the numerator and denominator can be reduced, but really that's all that we can do. So my final simplified answer, or rational expression, oops, not 3, would just have the 3x plus 2 times 1, which is just still 3x plus 2. And then the 5x squared times that x, when I multiply those together, will be 5x to the third. So this is my simplified expression, and these would be my undefined values. Okay, one more example of division, then I have one other one that I wanted to do that I saw on Khan Academy, or something similar to one of the problems that's on the Khan Academy. All right, so if in example B here, nothing can be factored out of all four parts. So you've got four trinomials here. All of them can be factored. So I will do one at a time, starting with the numerator. So this numerator, when I factor it into two binomials, the x squared factors into x and x, two numbers that multiply together equal 15, but subtract equal 2, 5 and 3. The 15 is negative, so my signs are going to be opposite. Larger is going to be positive. And then if you check it, 5 times negative 3 does equal negative 15. And the positive 5 and negative 3, when you add them together, does equal positive 2, x in the middle. All right, so now the denominator. Different color for that. Not too different, but a little bit different. All right, so my denominator now, the x squared minus 3x minus 40, when I factor that, again, factors into x and x. The factors of 40 that have a difference of 3, I'm drawing a blank, 8 and 5, so or 5 and 8. The larger one needs to be negative so that I get a negative 3 in the middle. So again, if I check, positive 5 times negative 8 does equal negative 40. Positive 5 plus negative 8 does equal negative 3. So these are the correct factors. All right, I'm not going to switch my I'm not going to switch to multiplication yet. I'm going to keep this division, and then I'm going to factor my numerator and denominator. So my numerator, the x squared plus 8x minus 9 can be factored into x plus 9 and x minus 1. My denominator can be factored into x plus 9 and x minus 8. So here we have something that's unique. We have a fraction that has a common factor in the numerator and denominator. So you don't have to keep that in there. You can reduce it at this point in time. But again, before you reduce, I would probably go down to the bottom here and state my undefined values before I mess anything up. So in my denominator, negative 5 would make this factor 0, so x cannot equal negative 5. X minus 8 would have a root of 8, so positive 8, so x cannot equal 8. Over here, I have x plus 9, so x cannot equal negative 9. Over here, I have x minus 8, again, so x cannot equal positive 8, but I've already got that right here, so I don't need to state it again. But after we do take the reciprocal of the second fraction, there will be one more undefined value that we get. All right, let me go to green now. All right, so all I'm going to do now in this next step is rewrite my first fraction. So my first fraction, actually, I don't have to do that. I can reduce that x plus 5 and reduce the x plus 9. Let me start that over again. Okay, so the x plus 5s can be reduced. So I really just have x minus 3 over x minus 8. The x plus 9s were reduced. So again, I'm going to change my multiplication now, or my division to multiplication, and take the reciprocal of this fraction. So the x minus 8 would go in the numerator. The x minus 1 would go in the denominator. So now my x minus 8s can be reduced. And all I have left then is x minus 3 in the numerator and x minus 1 in the denominator. So that is my simplified fraction, but don't forget to look for any other undefined values. We have an x minus 1 now in the denominator, so 1, x cannot equal positive 1. So that gives us our last and final undefined value. So this is our simplified rational. So this is simplified. And these are my undefined values, or values that would make our function, our denominator 0. Okay, there is one more example that I was going to do, and that is, like I said, similar to one that you might have come across on the Khan Academy assignments. I know some of those problems are a little bit tricky. So I'm going to say, I'm going to call this the KA example, so Khan Academy example. And again, I made this up. It's similar to some of the problems, but it's not exactly the same as any of the problems that are on there. All right, so let's say you have 4x squared minus 9y squared all over 3xy minus 2x squared, and it's being divided by x squared minus 4xy plus 3y squared, and then the denominator 4x to the fourth minus 4x to the third y. So I've got two different variables going on in here, which some of the problems in Khan Academy does do. So thought this would be a good place to start. All right, so taking your numerator, the first fraction, if you notice 4x squared and 9y squared are both perfect squares, and you have a minus sign in between. So this can be factored into a difference of two squares. So the square root of your 4x squared is 2x, and the square root of 9y squared is 3y. And then your signs, of course, are going to be opposite, so that when you multiply that positive times negative, you get that negative. All right, let's look at our denominator. So it's not a difference of squares, but they do have a common factor of x. That's really all I can do here is factor out an x, which then gives me 3y minus 2x. All right, moving on to the second fraction. Again, I'm not going to change this yet. I just want to focus on the factoring part first. So your x squared minus 4xy plus 3y squared, you would factor this just the same way you would as if you had x squared minus 4x plus 3. If we ignore the y's there just for a second, in order to get the x squared in front, you would have to have an x and an x. In order to get a positive 3, so you need two numbers that multiply together equal positive 3, but add up to negative 4. Well, those values are going to be negative 3 and negative 1. So the only difference right here is that we have a y squared. So behind the 3 and the 1, you have to put a y, so that when you multiply them together, you actually get positive 3y squared. All right, so in the denominator, again, look for like terms. You've got a 4 in common, and you've got x to the third that you can factor out. So 4x to the third. So if I factor out a 4x to the third from the first term, I'm going to have an x, and then minus the 4x to the third gets factored out, which gives me a y. All right, so now that I have everything factored, look to see if you can reduce anything. Well, if you look at this fraction over here, you've got x minus 1y and x minus 1y. Also for this example, I'm going to put in the directions, assume all variables are defined. What that does is enables me to just ignore the undefined value issue. And I'm doing that because there are two variables. So just assume that whenever you see that those words in the directions, basically that means don't worry about undefined values, just worry about simplifying the expression. Okay, so x minus y, I have it x minus y here, and I've got an x minus 1y here, which is the same as that. So we can reduce those factors. I can't reduce anything here. Now over here, I do have something kind of interesting. I've got a 2x minus 3y, and then a 3y minus 2x. They are very similar, but they're in the opposite order. So when you see this happening, you can reduce this, but not until you factor out a -1. So I'm just going to take this 3y minus 2x off to the side. And let's just switch the order. If I put the -2x in front and then the 3y is positive, so I put the plus 3y there, now it looks a little bit more like what we have in the numerator, but my signs are wrong. So I would want to factor out a -1 from both terms, which would then make this -2x a positive 2x and make that positive 3y a negative 3y. So that -1 would be multiplied with the x out here. So let me just so this 3y minus 2x, if I factor out a -1, so I'm basically putting this back up here, and I get 2x minus 3. But then I've got this x here that has to be multiplied with that -1. But now, I guess I'm going to cross this out because I've got all of it represented right here. I don't need to have it twice. So now that I factored out that -1 and rewrote this, I can reduce the 2x minus 3y in the numerator with the 2x minus 3y in the denominator. All right, so now since we've reduced what we could in each individual fraction, now we're going to finally tackle the division part. So what I have left in the first fraction is 2x plus 3y in the numerator, and the x times the -1 would be -1x, or just -x in the denominator. So I'm taking this, what I have left in the numerator, and that's what I have left in the denominator. I'm going to change my division now to multiplication, and whatever I had left in the numerator is going to go now in the denominator. And what I had in the denominator is going to go in the numerator. So now I have one more thing that I can reduce, and that is the x. So here I basically have an x to the first. Here I've got an x to the third. So I can take away an x from each of those. So if I take away x there and I take away x here, I will still have two x squared, or x times x, which is x squared, in the numerator. All right, so now I'm finally ready to write my simplified answer. So I have this 2x plus 3y times 4x squared. The monomial should always go in the front. And then in the denominator, I have just this -1 and this x minus 3y. So I'm going to go ahead and distribute that -1 and multiply it to both of those terms, making it negative x plus 3y. And that's how I will leave it. There's nothing else we can reduce, so we'll just leave it like that.